So Blender 3.6 came out a few days ago, and it came with a completely new geometry node feature called simulation nodes. So today we're going to use simulation nodes to create this bubble generator. So let's start by going into geometry nodes, and we're going to add in a new geometry node for our cube. We don't need the group input. What I want to start with instead is Shift A, add in an icosphere node. Connect that with the group output. And let's give this icosphere a subdivision level of 2 and a radius of 0.05. This icosphere is going to be our source from which the bubbles are going to rise from. We want to make it that this icosphere is going to follow a certain object. And that certain object is going to be an empty. So let's add in an empty by pressing Shift A and do empty plane axis. And we want that when we move this empty, that the icosphere is also moving along. So let's reference this empty in our geometry nodes with a object info node. Set that over here, set this on the empty. And we want to say, okay, the location of the icosphere should always be the same as the location of the empty. So we can do that with a set position node. And as the offset, we want to say the location of this empty. And now you will see if you move this empty, the icosphere will also move along. Let's now distribute a lot of points around our icosphere. Let's do that with a distribute points on faces node, like that. And let's set the density on 100, so that we have some points. Now that we have these points, we want to make them rise up. So from here, we're going to use the new simulation zone that Blender added in 3.6. So let's do search simulation zone. Let's make some space. And let's connect the distribute points on faces with the simulation input. And let's connect the simulation output to the group output. In the simulation input, that's where we have all the beginning states of our object. So we, for example, have the beginning geometry. And in the simulation output, we have the end geometry, so what it looks like at the end of the simulation. We want to tell Blender what is the beginning speed, the beginning velocity of our points. So you can do this by clicking on the simulation input, and if you press N, you can make this pop-up open, and then under simulation state, click on plus, and then you get a new geometry socket. Well, we don't want a new geometry socket, we want to make this velocity. And then instead of geometry, this should be a vector, so that we can actually say a direction in which the points are going. So let's set this from geometry to vector. But then you see, okay, the velocity in the beginning is now 0, 0, 0, so it's basically standing still. If you connect the beginning velocity with the end velocity, still nothing will happen if you press play. But if we use the velocity in combination with a set position node, so if you press Shift A, set position, you connect it with over here, and you set the velocity as the offset as well, and still nothing is happening, that's because the vector is still 0, 0, 0. If you make this now 1, and you reset the timeline, and you will see it goes very fast up. Let's set this a little bit lower to like 0.01 or something like that, and then you will see the points start rising. Because we're saying, okay, on the z-axis, it should move up every frame by a factor of 0.01. But you see, now it's just like one group of points that is rising up, right? But if we want to have bubbles, we need to have a lot of different groups of bubbles that are going to rise. For each new frame, we want to add in a new set of points. And we can do this by adding in a join geometry node and set this before the set position. And every single frame, we want to add in a new distribute points on faces. So connect that over here. And then if you press play, you will get this. Yeah, this doesn't really look good yet, right? So the reason why it doesn't look good yet is because with every single frame, it's adding in the exact same distribution of points. We want that for each frame, the seed value of this distribute points on faces is going to be different. So let's add in a scene time, and let's connect frame to seed. And now if you go back to frame 0 and you press play, you're getting kind of like bubbles already. I want to give each new group of points a random speed. So let's do that by adding in a random value node. This random value is going to have control over the z-axis of the velocity, of the starting velocity. So what we're going to do is we're going to add in a combine xyz node, and we want to put this as the beginning velocity. And now we have control over the separated x, y, and z, and the random value is going to be the z-axis. But then if you press play, you see it doesn't really work, right? That's because if you want to work with random value within simulation nodes, you will have to capture that random value before you do the simulation. So we want to capture the random value for each point after the distribute points on faces. Let's do that with a capture attribute node. And let's place that between the distribute points on faces and the simulation input. Let's connect the random value to the value of the attribute, and then the attribute of the capture attribute to the z of the combine xyz. Then it still doesn't work. That's because not only do we have to put the combine xyz into the beginning velocity, but we also have to add these random values to the new points. And we can do this with a vector math node and set this between the simulation input and simulation output, and add to the current velocity, add a new velocity to that. And now connect this new add node with the set position. And you see, still doesn't work. That's because we're still adding in the points before the capture attribute. We should not add in the points from the distribute points on faces, but we should add in the points from the capture attribute. So let's disconnect the distribute points on faces and let's connect that capture attribute with the joint geometry. And then you will see they start floating up. Way too fast, of course, but that's what we're going to fix now. Within the random value node, we want to change the minimum speed and the maximum speed. On the internet, it said the minimum speed of the water bubble is approximately 28 centimeters per second, and the maximum is 40 centimeters per second. So let's set the minimum value on 0.028, and let's set the max value on 0.04. And now if we press play, you see, yeah, that looks good. That's a good speed. The bubbles are now rising straight up, and in real life that's impossible. So let's add in some randomization in direction. I kind of want that it's going to be like spreading like this. So let's do that by adding in a noise texture into our geometry nodes. And this noise texture, we first want to normalize this with a vector math node. Set this from add to subtract, and I want to connect color with vector, and I want to subtract 0.5, but only on the x-axis and the y-axis, because I'm going to leave the z-axis for what it is. I'm not going to add in noise on that, because that needs to go up in a straight way. Let's click Shift D on this add node, and let's place that over here so that we can add our noise to this velocity. And now if you press play, you see, goes way too fast. Few things we want to fix. We want to make it go slower. Plus, we don't want it to be affected on the z-axis. So let's add in another vector math node, set that after the subtract, and we want to filter out the z-axis. So let's set this from add to multiply, and let's set the x and y on 1 and the z-axis on 0, so that that one will be filtered out. Now it goes like this, it's like spreading to all sides. We don't want that, so we want to make that effect a little bit less. And we can do that with a vector math node again. Set this after the multiply, and let's set this from add to scale so that we can change the scaling of this noise texture. Set the scale to a low value to like 0.005, something like that. And then you will see they will slowly scatter around. The cool thing about this is that when we take our empty and we move it, you see the bubbles will move along and they will rise from that point, and then it really looks like really realistic. Let's make it that the points are actually bubbles. So let's do that after the simulation output. Let's add in an instance on points nodes, and as the instance we want to add in an icosphere. Let's give it a resolution of 3 and let's connect it with instance. For the scaling, I kind of want it to be random, but I also want it to be dependent on the velocity that each point has. Because the higher the velocity, the bigger the bubble should be. Luckily for us, we have that data over here in the velocity. So let's add in, for the scaling, a combine XYZ node so that we have control over each individual socket, connected with the scale. Let's set this all on 1 for now, that's fine. And we want to extract from this velocity the Z velocity. So let's do a separate XYZ node and connect the velocity with the vector, and now we have the Z data. This Z data, we want to connect that with the X and with the Y of the combine XYZ. But also with the Z. And now you see if the velocity is lower, the ball is a little bit smaller. And if the velocity is higher, the ball is a little bit bigger. However, bubbles are never perfectly round. Bubbles are most of the time more like this. That's a good drawing, but something like that. Let's make this by adding in a math node. And let's set that between the Z and the Z over here. And let's set this on divide, and let's divide the Z-axis by 2. so that it's always kind of like this. I want to have more control over the different sizes between the bubbles. So what we can do is we can add in a map range node. And if we add in a map range node, we can add that in over here. And I want to combine these 3 lines into kind of like one line. So if you do shift and drag your right mouse to be like this, then you can combine it into one. Add in a map range node after this. At the moment, it goes from the minimum speed to the maximum speed. And we have that over here. We want that this minimum value of the random value node is always the same as the from min value of the map range node. Same for the max. So let's add in 2 value nodes like this. Let's set this on 0.028. Let's set this on 0.04. Add this one over here, add this one over there. These two, we're also going to add them in the from min and also in the from max value. And if you want to have more overview over your nodes, you can hold down shift and right mouse button to create like joints over here. And these joints, you can then move them like over here. And you can do that again and then move them like this, that you keep your overview. Now we have more control over the scaling, because if we make the 2 max value, if we make that lower, you see we can make the difference between smaller and bigger bubbles higher. I kind of like this actually. Maybe make this 0.01. Yeah, I like that. When bubbles rise, they are never the same shape in the whole rising process. They always go up like this, right? So let's create that displacement with a set position node after the instance on points. We also want to realize our instances so that we can actually do the set position. So let's add in realize instances node. But with the set position, we want to do a noise texture. And to be honest, let's save us some time and let's take this noise texture and also the subtract and the multiply node. And let's press Shift D to move it over here. Now if you make this multiply node, let's set it on scale. And let's connect the scaling to the offset of the set position. Then you see it will go like this. Yeah, that's not looking like bubbles at all. Let's set the scaling a little bit lower. And let's also set in the subtract node the z-axis on 0.5 as well. And now if you set the scaling lower, like very low, you can make it like this. And then the bubbles start to go up like that. By the way, you now also see that the bubbles are mostly going into one direction, kind of like that. I want to have even more randomization in the X and Y direction. So in the noise texture, the first noise texture, let's set the scaling up and the roughness all the way to 1. And then you're getting more like this. Let's do shade smooth for the bubbles, and let's do that with a node. Let's do set shade smooth after the set position, and then they look smooth like real bubbles. Now I think this effect is already pretty cool, but I think we can add in just a little bit extra, because at the moment, if I would add in an object, yeah, the bubbles are not going to react to it, right? They are going to pass right through it. Would be cool if we can make it that the bubbles would react to actual objects in our scene. For that work, we are going to do some mathematics, so don't get scared by the amount of mathematic nodes that we're going to add in. Let's just do it, and let's see. I'm going to add in a new object, and just for this example, I'm going to add in a plane, which I'm going to place right over here. And I'm going to rotate it a bit so that the particles can go sliding over it. When we press play, we see, yeah, the particles are going through it. So let's fix that. Let's make it that it's going like this. First thing that I want to do is I want to create a whole new collection in our scene that our bubbles are going to interact with. To place this plane into a new collection, you can click on it and press M and do new collection. And you can name this like collision or something like that. Now if you go back into the bubbles and we import the collection info node so that we can reference our collection inside the geometry nodes, set this on collision. And let's set this on relative and also separate children. When you add in a collection info node, Blender sees every object that is inside of that collection as an instance, but we don't want that. So let's add in a realize instances node so that Blender sees this as real objects. For each bubble, we want to find what face is the closest to it and what is the normal of that face. So to find the nearest face, we can add in a sample nearest node. And to find the normal of that nearest face, we want to do a sample index node. Set the sample nearest from point to face and in the sample index also point to face. Connect the realized instances with both geometries. And let's set the index into the index of the sample nearest. This sample nearest, we don't want to get a float. We want to get a vector because we want to have the normal data. So let's add in a normal node. And this normal, we want to connect that with the value of the sample nearest. And this way we can collect the normal value of the closest face of each point. We want to calculate a few things. The first thing that we want to calculate is when is the distance between each point to the face. And we can do this with a geometry proximity node. And as the target, we do the realize instances. We want to say, okay, when the distance is lower than a certain value, we want to make the effect work on the bubbles. So let's add in a math node and let's set this from add to less than, and let's set the distance as the value. And then you'll see if you do Ctrl-Shift-Click on this node and you also Ctrl-Shift-Click on the simulation output, then you see the points that are white, it means that they are close enough to the plane. The lower you set this less than value, the smaller this threshold is going to be. I found out that the value of 0.2 works the best. You see, now it is like this. The points that are white are like on both sides of the plane. But we want them only to be white on the bottom of the plane, because when they are above the plane, the effect should not work anymore. So we want to calculate where is the normal of the face in the opposite direction of the velocity of the particles. And we can get this information by getting the dot product between the normal of each face and the current velocity. So let's add in a vector math node. Let's set this on dot product. And we want to have the dot product between the original velocity and the normal of a face. This dot product is 1 for each point when it's like below the face, but 0 when it's above it. To see the effect of the dot product, you want to add in a math node and set this on less than as well. You then connect the value over here and set the threshold on 0. If you now do Ctrl-Shift-Click on this node, then you see it doesn't do anything. That's because we have to normalize these two vectors. So let's add in another vector math node over here and let's set this on normalize, and let's also set this one on normalize. Then you see it's still all black. That's because the plane is flat, and this only works with objects that have actual volume. So let's click on the plane and let's go into edit mode and let's just extrude this a little bit with E. And now if you go back into the geometry nodes, then you see everywhere where it's like below, it's white, and once it's up, it becomes like black. So we want to multiply the two less thans together with a math node, and let's set this on multiply and multiply them together. Let's see what that looks like. Looks like this. Cool, now we have like a mask so that we can determine on which points should the effect take place. To calculate the new direction of each point, we're going to use another vector math node. And let me actually make some space over here. And let's set this new vector math node from add to reflect. What this does is it's basically saying, okay, when a point goes over here, over here, over here, over here, it's going to interact with this and then it will reflect from that face. So it will go kind of like this, and then it goes up and it goes up and it goes up and it goes up like that. So let's reflect the original speed as the first one, and we want to reflect that with the normal of each face. This new reflect, we want to mix that with the original speed, so that it's either going to be the reflective vector or the original speed vector. Do this with a mix node, set this from float to vector. As the vector, we want to do the mask that we created earlier. And let me also delete this viewer node, by the way, we don't really need it anymore. And I'm also going to create some space between here and there, like this. Back to our mix node. Our vector A is going to be our original vector, so our original speed. So let's set this add value to vector A, and the reflect is going to be vector B. And now if you add this mix node into the first set position that we added in, we're getting this effect. This is already cool, it's already interacting with it. However, it's like bounce, 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 bounce. And that's not what we want. The reason for this is because the reflect is doing it also on the z-axis. It's affecting the z-axis, but we only want it to affect the x and y. Because if it's going to do the z-axis as well, yeah, then it will bounce, bounce, bounce. So let's make it that the z doesn't change. Let's do this with a separate XYZ node. And we want to separate from the original speed. We want to gather the Z-axis. Let's also add in a separate XYZ for the reflect. And then we want to say, okay, with a combined XYZ node, the X should stay the same, the Y should stay the same as the reflecting, but the Z should be the same as the original speed. And this is going to be our vector B. And if we now play it, then let's see, then it doesn't do anything. For some reason, I disconnected the join geometry of the set position, so I will connect that again. Yeah, otherwise it's not going to work, of course. But now it works, and if we do it like this, then you see, voila, there is our effect. And this works with every object. So if we do Shift A and we add in, for example, a UV sphere, and we place this UV sphere like on top of here, and we say, okay, this UV sphere should also be in the collision collection. So we press M and we move this to collision. Now if we press play, it should be that the bubbles are also going to react with our UV sphere. And that is the case, as you see. And now we have created a very, very, very powerful tool. I think you can create pretty cool renders with this. One final thing for this bubble generator, of course, is the material. We're going to make this very easy. So let's split our screen in half over here. Let's change this to the shader editor and let's create a new material. We're going to delete the principal BSDF and we're just going to add in a glass BSDF, connect this with the volume, and let's set the IOR value on 0.33333. That's the IOR value of water. If you now go into material preview mode, then you see the material is not added into our object. That's because we have to say in geometry nodes what the material should be. So let's set a set material node over here and let's set this on our material. Of course, I should not set it on volume. I should set it on surface, of course. Then it works. Sometimes you want to say, okay, now I want bubbles, now I don't want bubbles. Now I want bubbles, now I don't want bubbles. Add in a switch node for that and set the capture attribute on true and the output to the join geometry. And now you can say, okay, sometimes it doesn't do geometry, sometimes it does. If you set this off, then you're not getting bubbles, of course. If you now set the switch on, then you're getting bubbles. If you're taking it off, you're getting no bubbles. You turn it on, you get bubbles, off, no bubbles. So there we have our bubble generated, completely created in geometry nodes with the new simulation nodes. If you want to be sure that you have all the nodes right, I have a screenshot of the nodes in the description down below. If you like this video, please give it a thumbs up. Comment down below if you have any questions. And if you want to help out the channel, please consider subscribing. And with that being said, I cannot wait to see all the results that people are going to make with this bubble generator. See you in the next one.